Okay, we're going to look at MR support for section 5A. So the first thing I'm going to do is describe to you what we mean when we talk about a confidence interval. So a confidence interval is a range of values that we obtain by subtracting and adding the margin of error to the sample statistic. Okay, so if I know a sample statistic that they're giving me, so let me draw what I'm going to talk about here. So here's my sample statistic. So to find the left endpoint of my confidence interval, I'm going to take this sample statistic and subtract the margin of error. Because by subtracting that margin of error, I'm always going to get a number less than the sample statistic. And then to get to the right endpoint, I'm going to take the sample statistic and I'm going to add my margin of error. So that's always going to give me a number bigger than my sample statistic. So technically, this section from the left all the way to the right would be what we would call the confidence interval. Okay? So that's where we would expect our parameters to fall, is inside of what we call our confidence interval. Okay? So I'm going to do a few examples like you had in your support homework to show you what they're talking about on their problems. Okay? So this first example, they say the following summary of a statistical study gives a sample statistic and a margin of error. They want me to find the confidence interval and answer any additional questions. So they're telling me a poll is conducted the day before a state election for senator. There are only 2 candidates running for the office. The poll results show that 55% of the voters, so 55% of the voters, favor the Republican. Okay? Now, with a margin of error of 2%, so that's my margin of error. So should we expect the Republican to win? Why or why not? So what we want to do, if this is 55% of the voters that voted for a Republican, we're going to set up our confidence interval. So let's set up the confidence interval. 55 is my sample statistic they're giving me, and then I'm going to subtract 2%, and then I'm going to add 2%. So here we go. So here's my statistic at 55. So if I subtract 2 from 55, that'll give me 53. So we did 55 minus 2 equal to that, got my 53. So that's going to be the left side of my confidence interval. Now I need to find that right side, which says I take 55, which is my sample statistic, and I add my 2%. So 55 plus 2 would give me 57. So right here we did plus 2 and got 57. So our confidence interval is going to be from 53% to 57%. So that's the range that we're expecting our Republicans to get. So they're asking, should the Republican expect to win? Why or why not? I would say yes, because our confidence interval shows me that at least 53% Republicans are going to be voted for, up to a max of 57% of the voters going to the Republicans. So since 53 to 57, both of my confidence interval values are higher than the 50% it takes to win the election. Since both these numbers are higher, I would say yes, definitely I'm going to expect them to win, okay? So that's what they wanted you to do on number 1 on here. Get the confidence interval and see if it favors that Republican winning, okay? Alright, so let's go to number 2 that they were doing on the homework. So sort of the same thing, we're going to mess with the confidence interval again. So it says a national survey of 1,517 respondents reached on landlines and cell phones found that the percentage of adults who favor legalized abortion has dropped from 52% a year ago to 45%. So we're looking at 45% now, okay? The study claimed that the error attributable to sampling is plus or minus 4%. So that's going to be my error. Would you claim that a majority of people are not in favor of legalized abortion? So we just want to find a confidence interval on this, because remember, this is showing the people that actually don't, this is the percentage of adults who favor legalized abortion. So it used to be 52%, but it's 45% now. So we're wanting to look at what's happening now versus that past, okay? So we're going to set up our confidence interval using our 45%. We'll subtract 4 from that and get our left end point. So let's see, 45 minus 4 would be 41% on the left end point. Over here, on the right end point, I would do 45 plus 4, which is 49. So if this is the number of people who favor abortion, they wanted to know, could you claim that a majority of the people favored abortion? Well, y'all, my confidence interval is only going from 41% to 49%. Remember, majority has to be 50% or higher. So since this is really below my 50%, and this is the people who favored abortion, I would have to say that yes, the majority of people are not in favor of legalized abortion. And that's because all of our intervals are below 50%, okay? Alright, let's see what I got you doing next. So the next is a few definitions real quick, and then I'll sort of show you what that last problem is going to do. So support, we kept it light today. So we're going to look at 2 things that determine how they get their test statistics and what methods they use, okay? So we're going to look at what we call an observational study. And really, an observational study is pretty much what it says. The researchers observe or measure characteristics of the sample members, but do not attempt to influence or modify those characteristics. So they do not attempt to influence or modify those characteristics. So it's like they're just watching. They're not doing anything. It's like this observer is just sitting outside and say I wanted to do a sample of how many men hold the doors for their wives or their girlfriends or any female. I'm going to sit somewhere and I'm going to watch people go inside and see who's opening that door for their women and who's not. That I'm just observing it. I'm not trying to change the outcomes by doing anything to it. I'm just sitting there and observing this study, okay? Now the other one is the experiment. The experiment, the researchers apply a treatment. So the researchers apply a treatment to some or all of the sample members and then observes the effects of the treatment. So using an experiment, they'll have what they call the experimental group. You'll have your treatment group, I guess you might call it. So you'll have a treatment group. You might have what we call a control group. So if I was going to test a vaccine, I would give my treatment group the true vaccine that I made. I would give my control group a placebo or a fake drug. It's not going to be the treatment, okay? Because I want to observe whether they think they're getting better or not based on these placebos. I got to treat that, take those into effect when I'm doing my treatment group to see how these treatments are working on them. So we also do what we call a blind treatment. A blind treatment is when the participants don't know who is going to get the treatment or the placebo. So the participants don't know about who's getting what. A double-blind treatment, the people getting the treatments don't know, and the researchers don't know. That way the researcher can't be biased, you see what I'm saying, and say, well, it worked on the ones that had the treatment, but it didn't work on the others. No, if the researcher don't know who's getting the medicine, just like the people don't know who's getting the medicine, when he's analyzing it and observing it, he can't be influenced or biased, okay? So we always want a good treatment to be double-blind if it's going for medicine and stuff, okay? So let's see, I'm going to give you one more problem in this support that they have. In this example, we're going to determine whether the following study is an observational study or an experiment. If it's an experiment, we're going to identify the control and treatment groups and discuss whether single or double blinding is necessary. If it's observational, we're going to state whether it is a case control study, and if so, identify the case and controls. Alright, so in a study of the effects of magnets on back pain, some participants were treated with magnets while others were given non-magnetic objects with a similar appearance. So we made them think they had magnets, although they weren't magnets. So the magnets did not appear to be effective in treating back pain. So, was that observational or experimental? So remember, since they're trying to influence it or change the outcomes, it is definitely experimental. Remember, on the observationals, I don't do nothing. I just sit there and watch them. Or I do what we call, if you do like a retrospective observation, that's just where you're going and looking through stuff that's already been published about that, and you're using their data. Okay? Now, we got to figure out the treatment group and the control group. So I said the treatment group was the patients that used the magnets. Right? They're the ones that were trying our procedure on, was the patients with the magnets. The control group, well, that has to be the other ones that had the placebo or the fake magnet. So this would be patients with placebo or the fake magnets, so that you remember what that placebo means. So, your treatment group, control group, because you want to always have a control group to make sure that that medicine's really working on those and it's not something else causing that effect. And if my control group was getting better just like my experimental people were getting better, then does that mean my medicine's working or not? So I got to have a control group to know whether it's the medicine causing those changes, okay? Now, the best way to do this, like I said a while ago, you want to do a double blind. When you're testing out things like magnets, you don't want you don't want the experimental person to know that you're using the magnet and the fake magnet, because they might be biased and say, well, I think these people with the magnets actually got better because I know this person, and this person all seem to improve, whereas my others did not seem to improve. So they might be biased, especially if they're doing the research on something that they came up with. Okay? So y'all, this was just a short lesson getting you ready for what's coming up in Chapter 5. So, main thing on here was my confidence interval I went over with you. Subtract the error, add the error to the simple statistic to get the confidence interval. And then we looked at the two types of studies. You got an observational study and an experimental study. Okay? They try to change the effects in the experiment. We're on the observational. They're just watching it or looking for data from the past. Okay? So, knock this out. Next week we will get into 5A and MR and start getting really deep into our statistics. So y'all, good luck.